Perfect.
And
so you just signed up earlier than you would have gotten.
Yeah, because the thing with me was, if I wanted to be paid, I would have to wait like 6 weeks for a background check, and that would have like been half my summer. So I decided to just go in.
Was that going to be with co-op? Because I don't think that was going to be paid either, unless it was with some other group. Is it NREP?
Not sure.
Okay.
Yeah.
Yeah, I think that might have been a miscommunication. Because I remember Kathleen said, no, he's not going to get paid in that one.
I don't know.
But the point is, you do it for the experience, because it's really cutting edge stuff.
Yeah.
And then, so after he's finished, if you have any questions about UC San Diego, or what's also kind of interesting is that you can kind of tell them like the ropes around NPC.
Yeah.
So anyway, without further ado, please welcome Amir.
Thank you. Yeah, so my name's Amir. I spent 2 years at MPC, straight out of high school, because I didn't really know what I wanted to do exactly. I knew I wanted to be like in the engineering like realm, but I wasn't sure. So I took my time here to really like be confident in what I wanted to do, and ultimately I chose computer engineering as my path.
Before you transferred?
Before I transferred, yeah.
What high school were you at?
I was at Monterey High.
Okay, cool.
Yeah, I transferred to UC San Diego last fall, so finished my first year there, and I got 2 more years. So, yeah, and I'll be talking about my internship. All right.
And feel free to interrupt, right?
Yeah, if you guys have questions, feel free to ask, and then I'll have like a time at the end where you can ask any questions. So the first thing I did when I got to NPS was I worked in their systems engineering department, by the way. So systems engineering is kind of like a big mesh of like all different types of engineering. Like we got all these different types of engineers in there because they make systems work together. So
what kind of systems?
So mostly they work with like UAVs,
okay,
like drones, robots. They have underwater systems.
Can you explain what a system is? You know, that's something that I got into systems engineering myself.
Okay.
And they don't like tell you this in school.
Yeah, yeah.
It's a grad program usually.
That's something, something I learned, picked up over the summer.
Yeah.
So for the majority of my summer, I worked on drones. Like I built these drones, and a drone is a system. It has motors, it has speed controls, it has, you know, it has a GPS, a flight controller on it, and all these different systems have to communicate with each other in order to have like a proper flight, right? So you have an IMU, which is pretty much measures like, you know, your altitude, pressure, all these things that you need to know. That all these things feed into the flight controller, and the flight controller calibrates and makes corrections and things of that nature. So in essence, all these systems have to communicate with each other, and yeah. Is that kind of?
Yeah, that's basically it. Yeah. So, and system engineers actually work at the system level.
Yeah.
You get engineers that will just design motors, or engineers that will just design those controllers.
Yeah.
And then system engineers actually are responsible for putting it all together and making sure it all works.
Yeah.
I should say that there's like kind of a weird effect because you're standing in front of your text.
Oh.
And so you're getting letters appearing across your face. I don't know if that's uncomfortable for you.
I'll stand over here.
Yeah.
All right. So when I first got there, my mentor kind of wanted to like test the waters with me. He wasn't really sure how much I knew. So we started off working with this. So this is called a Raspberry Pi. It's a microcontroller. So in essence, it's like a small computer. It's a very weak computer, but I'll pass this around, and you guys can see it has like 4 USB ports, an Ethernet port, an auxiliary port, HDMI. The hard drive is actually right here. This is an SD card. And these Raspberry Pi 3s actually have Wi-Fi capability. So pass that around so you guys can take a look. So I started off working with Raspberry Pis, and I was doing pretty simple stuff. Raspberry Pis, working with LEDs. So I started off on a breadboard. I had several LEDs, and I made, you know, these cool patterns or whatever, you know, light up using the Raspberry Pi. And the way that works is the Raspberry Pi has input-output pins that can like give a voltage or like put out a voltage, and you know that makes a LED light up. And then from that, I moved on to, I used a Raspberry Pi with bit register, which a register takes, so if you guys know like ones and zeros, it's binary, right? That can be converted to a hexadecimal value. And a register takes in those values, and depending on what you give it, it will make certain pins, give certain pins a voltage, and that way you can make LEDs light up. So that might not exactly make sense right now, but I'll show you guys something that I did with the register. Let's see. Yeah, so you guys can see the 8 pins here, or the 8 LEDs. And so pretty much what I did was I don't know if you guys know what Knight Rider is, but it's like a movie where,
TV show.
Yeah, TV show. I didn't know what it was before. My mentor told me. But
it's kind of before your time. Probably.
Yeah, exactly. He has a car and
Car named Kit.
Yeah. See, you know more than I know about this. But pretty much the LED has this effect where it's bouncing back and forth. And that's what I did with the register. So you can't really see here because all these wires, you know, I took this video for my own personal like memory, I guess. I never had the intention of showing it to someone, but yeah, the register's under here. It just looks like a chip pretty much. So, and here, I'll show you guys what it is. So if you guys can see, the light is bouncing back and forth. And yeah, now I go to the oscilloscope. If you guys see here, this is the clock. It's called the clock. It's pretty much a signal. It goes in, and it's a bunch of ones and zeros. And this oscilloscope is just measuring what is being put in to the circuit. I'll play that one more time for you guys. It's very brief, but the light bounces back and forth. And that was what I started off with. All right. Then I worked with some motors, servo motors. To be exact, servo motors are high torque motors. So like if your finger gets stuck, they can break your finger, but like they move very slowly. So they're used in like robots to pick up things and stuff like that. So with a motor on a breadboard, I put these different buttons that handle different events. And these events, pretty much, if you press this button, it does this. And that was done on the Raspberry Pi as well. And these events are handled using Python scripts. So I don't have any of my scripts on this computer, but yeah. Then I moved on to a networking application with the Raspberry Pis. So in a network, you have a server and a client. And a server pretty much is kind of broadcasting, and the client connects. So I started off my application pretty much, it was internal, so it ran on the Raspberry Pi. So it talked to itself pretty much. And eventually I moved on to where I had 2 different Raspberry Pis, and they can communicate with each other. So I could have one in this room, and I could send something to, one across campus. And that was my first introduction into networking. I had never done something like that before. Yeah, like an application of that could be, you have your phone, which could be the client, and maybe you want to open your garage door with your phone. You could send a command with your phone, the client telling the server to do some sort of action. And that's pretty much all that I got to with the networking. Yeah, so the vision of this networking application was to have one Raspberry Pi communicate to another, telling it to perform certain actions like maybe turning a light on, or I don't know if you guys have ever seen Raspberry Pi projects before, but a lot of times they're using some sort of like networking idea to, if they're like using their phone to control something at home. Let's see. And then once I was done with that networking stuff, this was like the bulk of my summer, was working on these drones. So the reason we built all these drones was because we could have more flexibility in what we wanted. So instead of like going out and buying a drone, which is all, looks pretty and is packaged up for you, can't really do much with most drones that you buy. So the idea was we can have control over what we want in the drone. We can swap out, for stronger motors, or we can, maybe we want a better GPS that's more accurate, or we want the drone to carry a heavier load. So that was the idea behind the drones. And also by building these drones, we saved a lot of money, because I think each drone we built from scratch cost about $1,100, $1,200 maybe. And so that was all the parts, and then we built them ourselves. So, I mean, I guess labor is free. But if you were to buy drones with the same capabilities, they would run you about $6,000. So, and that's per drone. And we wanted to have multiple drones so they can be like a fleet of drones, so they can fly together. And and it was autonomous flight as well. So they fly like on their own. You give them a mission, quote unquote, and they follow whatever mission you give it. And we actually had, at the school, we had a police officer who worked for the Naval Postgraduate School. He was really interested in what we were doing, and he wanted to build his own drone for policing. He was telling us sometimes you can't get close enough to someone to like see if they have something on them. So a drone can be used for that. A drone with a camera can fly right over and get exactly like what view you want. Drones are used in agriculture to patrol like large farm areas. Drones are used by the military for like search and rescue purposes now. Yeah, so drones are like the next big thing, and that's what we were doing. So I'm going to show you guys some pictures. And this is like the different phases of building the drones. So this first picture here, you see this is a PCB board right here. And these are called electronic speed controls. So if you were to fly your drone manually and you push up on the throttle, it tells the speed control, lift higher or whatever. And so these wires had to be soldered on. So we soldered these onto the PCB board. This right here is for power. So this was soldered on. The battery connector was also soldered onto the wires. So a lot of times, especially if you're like electrical engineering or computer engineering, you'll have to learn soldering. That's kind of like one of the basic skills those types of engineers have. So that was like the very first step. And then we can attach the frame arms to the board. And then these were landing gears that we bought additionally. And attach the frame arms, that's a pretty simple step. Just a bunch of screws, really. And then attach the top PCB board. PCB, I think Tom.
A printed circuit board.
Yeah, I always forget.
Printed circuit board. Yeah, so they lay traces on the fiberglass to connect different points, and
so that you can solder to it.
Well, it's also for automation, because then you can get these other machines that just plant the chips in the holes, and then they have automatic soldering things too. That will just so manufacturing electronics is there's a lot of automation there, and PC boards are kind of the basics of that.
Yeah. So underneath here, you can see you see this little gold tint to it. That's what I soldered on to like make the connection.
So do you guys design all this too, the whole thing?
No, like the board?
Yeah.
No, we did not design that.
Okay.
So that is provided by a drone company, I believe DJI.
Okay.
Yeah, they make and sell their own drones, but this is like more of a do-it-yourself type thing. Yeah, and then so once the frame is put together, we put on the motors. So the motors are attached at the end. These electronic speed controls are then mounted to the frame arms, and we mount those with 3D printed brackets. And so that was our own design, was the 3D print. I don't think I have another step. So there's like a big jump from the last slide to this slide, because once again, I didn't take these pictures in mind of like showing.
Always a good idea to take a lot of photos when you're building something. Though.
Yeah,
you never do enough, but what you have is good.
So I don't know if the picture's not that great of quality, but I'll try to explain what's going on here. So as you can see, this is a protection around the drone. The propellers are on. The battery is strapped to the bottom. This is the GPS. The flight controller right here is mounted to the front. And that is kind of like the brain of the drone that handles the majority of the work. This is a radio for manual operation. Radio antennas, it's kind of hard to see because there's very little contrast. There's a safety buzzer here that's like, if you crash your drone, you have no idea where it is. Turn the buzzer on, it starts beeping. You could, find your drone that way.
Did you guys integrate like FPV systems at one point, or were you thinking about it?
We did not, but we did have
What's FPV?
FPV is first person view. So
right.
you have this like goggles on, and you can fly it with like first person. So actually, the systems engineering department bought like 20 like FPV drones, but like ready to go, and those were maybe not 20, maybe 10 or something, but they bought a lot. And they bought racing drones, like FPV racing drones, and those were actually really painful to fly, because especially if you're not like very comfortable with like flying a drone, because they just like fly really fast and they make all these like sharp turns. If you've never flown a drone before, that's not where you want to start, and that's where I started. So, but yeah, so we do have them, but this was a separate project.
And those are meant to be autonomous, so that they actually fly by themselves.
Right.
So you wouldn't really have to have anybody looking through the eyes.
Right. So this is a system diagram of the drone. So the flight controller, once again, is like the brain. So it takes in GPS, radio, receiver, a buzzer, and the power as inputs. And it outputs data to the electronic speed controls to tell the motors how fast to spin. The battery goes into it's called a power brick. It's like a way to manage how much voltage you're giving the flight controller and how much voltage you're giving the speed controls as well. So this system diagram is very specific to what the drones that we built. You can see this is the GPS we use. This is the radio we use. Yeah. Do you guys have any questions on this diagram? I know it's kind of hard to read, but. Lastly, this is a video of one of our drones. So I had another more interesting video of like our drone crashing, but, my mentor's like on vacation right now, so it's kind of hard to like get all this stuff together. But this is one of the labs we have. As you can see, we have like a net all around the lab, and we stand behind the net because like drones do fly unexpectedly sometimes when you're first testing them out. Like the first time we tested it out.
Do you got to wear a helmet when you're?
No, we didn't wear helmets. We just stood back. It was Rushin and I and another one of the engineers, and we're standing behind the net. And he goes to lift the drone, and it flies up and straight. It crashed like somewhere here, and it just like got stuck in the net. Yeah, it was really interesting actually, because I expected it to work fine, but I mean, I don't think that ever is really the case.
So did you guys write all the software for it too?
We did not write the software,
okay.
But the software we use it's called Mission Planner. It's open source. Yeah.
What was the cause of the fault when it went straight into the head?
The motors were not calibrated properly, so that's also done using Mission Planner.
Okay.
And also, I believe that so we were flying it manually, and so the motors weren't calibrated properly, and the remote was backwards. So if you wanted to like roll this way, it was going the other way. So it was just kind of unexpected. But let's see if I can do this. So yeah, just flying in there. You can see like we have other stuff behind there, but yeah, that was the bulk of my time at the postgraduate school. Was working on drones.
When was that you were working on?
I'm sorry?
When was it?
This was like this summer. So I finished 2 weeks ago, actually.
But you're still there, right? Or no?
No, I'm not.
Okay.
Yeah. My last week was, yeah, about 2 weeks ago, week and a half ago.
You guys build any larger drones?
I did not, but like, as you can see, might be hard to see, but this right here is a helicopter. And this thing is probably like that size. I didn't work on those, but those were like past student projects because so pretty much at this engineering department, the systems engineering department, they support classes for students who are doing their theses. So like if a student wants to do a thesis on UAV helicopters or something, they support it, right? Yeah, there's a bunch of like unfinished projects all around that students couldn't get working and things of that nature. So. Yeah, so do you guys have any questions for me? Yeah.
So you like started off like learning how to like use like the Raspberry Pi and stuff, and then you like learned how to like connect and like network them and started making games.
Yeah, so it's not very
Linear.
it's not like a logical step onto like drones, but yeah, I did start off with Raspberry Pis. I had never used a Raspberry Pi before that. I had used Arduinos, which are similar to Raspberry Pis, but yeah, so he kind of wanted me to like, and he wanted me to learn how to use Raspberry Pis because actually the next step for our drones is to attach a Raspberry Pi to it and use that with the flight controller. And the reason for that is so we can have different drones communicate with each other using the Raspberry Pis. Yeah, and also I started off with using Raspberry Pis because I had never programmed in Python before. So, you know, I learned Python over the summer. I put my email up here because I know sometimes, you know, students don't want to ask questions. So if you guys want to anonymously like send me an email.
You know the audience well.
Yeah. Yeah. When I went to UCSD, I saw, you know, guest speaker. He did this, and I thought that was a great idea. So
cool.
Page from his book. Yeah.
For the server and receiver, were you also learning that in the internship?
Yeah, yeah. So that was networking was something I've never done before. So he kind of would, my mentor, he would kind of just throw me in and be like, "You've never done this before, like make it work," sort of thing. And it was fun. At the end, it was really frustrating, but it was fun.
You also said that you were using Arduinos and the Raspberry Pi. Why Raspberry Pi?
Honestly, I couldn't tell you. It's just like, I think it's a choice.
I think it's a little more powerful than the Arduino.
Yeah, I think you could do more with Raspberry Pis, but you can still accomplish the same thing with an Arduino.
Probably, yeah.
Yeah.
Did your Raspberry Pi already come with all the USB ports and auxiliary ports, or did you have that?
No, so it comes with all that stuff, and
Probably why people like it.
yeah, yeah. So you can run. So actually, if I had a monitor right now, a monitor, a mouse, and a keyboard, and I could plug that into the Raspberry Pi, and it works just like a computer. It has, you know, that one specifically is running something called Raspbian. So you have like, you know, the user interface you would have on like Windows 7, but it's like slightly different. I ran at what's called a headless setup. So I don't know if you've ever like used the terminal on your computer before, but it looks kind of like that, and you use Unix commands to do different things with it. That's a little bit faster way to use your iPad. Yeah. Yeah.
Do you still want to continue with drones, or is there like other things they want to plan for the future?
So I think drones were really fun, but like this isn't something I would want to do like as a career. It was fun, and I learned a lot from drones that I can apply to other different projects, but drones specifically, not really.
What kind of projects would you apply this on? Or what areas are you more interested in?
Well, anything in, you know, in robotics, you
Okay.
can use with that. Yeah.
What about drones wasn't appealing to you?
The whole like flying that I just didn't like.
Okay.
I don't know. I was because these are not like cheap.
So you're worried
Toys.
about destroying a lot of hardware?
Yeah.
Yeah, I guess I would find that kind of worrisome too, as a
Yeah,
beginner. But then, you know, after you're working in a place like that, you realize, well, of course, you're not getting paid,
Yeah.
so you're helping them a lot. And even if
Yeah.
if it blow up a couple of them, it's still a good deal for them.
Yeah. No. Just. Yeah. I don't know. It's just flying the drones was not very. It was fun, but I was kind of worried a lot of the time because like they would just give me for the FPV racing drones, like they gave me that for the weekend. And they're like, yeah, you know, have fun with it. But, you know, as soon as you touch the throttle, it flies straight up. And then as soon as you know, maybe you want to roll this way, it's so sensitive. So if you've never flown a drone before, you know, it's hard to do. And a lot of the students were flying their drones and they crashed a lot. But I mean, they're all like military officers. So, and then there's me. Yeah. So. Yeah.
Will you try to do this next year?
With NPS?
Yeah.
I will be applying to NPS again, but I'll be applying to other places as well because I want to get my feet in like different companies and see what's out there and stuff.
So the NREP program would be paid, I think, if you applied to that.
So if you want to do this, you would have to apply by October 31st, I believe, is the deadline. Don't quote me on that, but you can go to I believe the domain is nreip.org if you're interested in that. So. And that would be a paid opportunity.
Mm-hmm.
So. Any questions? Do you guys have questions about UCSD or transferring or? Yeah. Okay. I'll start off by saying at MPC, I think the teachers really wanted you to learn the material, and it was a great environment to learn in. Whereas when you like transfer, no one really like pays attention to you. So it's not that the material is harder, it's just that you have to like go out of your way a little bit more. I don't think like the difficulty in classes, for me was not huge. There is like some sort of jump, but it's not huge. I think as an MPC student, I think I was more prepared coming in than students who had started their first years.
Would you do anything differently about your coursework here at NPC, knowing where you are now, or?
Would I do anything differently? Well,
did you make any mistakes in terms of taking classes here? That
I think I kind of got lucky because when I was here, the counselors told me you don't need to do like for engineering majors. They told me you don't need to worry about IGETC and all that stuff. But when I was taking classes here, I would take, random like general ed classes because, I was interested in stuff and I was like, why not, But in the end, I finished IGETC even though I was told I didn't need it. And in the end, that saved me a ton of time because had I not finished IGETC, I would have had to do the whole general ed sequence at UCSD, which, what's the point of going to a community college if you have to start from scratch anyways? So I would just say like...
That's interesting because, the standard advice is that, well, the reason they want you to not focus on IGETC is because you really have to prove that you can do engineering by succeeding in calculus and physics,
right,
chemistry, engineering classes. Because if you can, take all the IGETC you want, if you haven't taken calculus or all these other classes when you transfer, you're still going to be there for 4 years too.
Yeah.
But in your case, it kind of worked out as it's better to do both if you can.
Yeah.
And so if you got through all of your engineering prep classes and you maybe did 3/4 of your IGETC, would you have to take all the IGETC over again?
Yeah. I would have to do all my general ed classes. Even
though they articulate, I think that's crazy.
Well, so actually for IGETC, I took psychology and sociology, classes of that nature, which I think most of them don't articulate to classes at UCSD.
Yeah.
So, but by finishing IGETC, I finished general ed. If that makes sense. Yeah. Yeah, I would just say if you have your eyes set on a school, really look into it because I kind of got lucky and saved myself time. I ended up taking 12 units over summer. Well, I got lucky, but I also took 12 units over summer so I can finish IGETC, so I didn't have to do that general ed once I got there. Yeah.
Did those summer classes affect your schedule NPS at all?
Oh, that was the previous summer. So I think that summer I did that and I worked for Tom, and that was pretty much what I did.
Right.
This summer I didn't take any classes.
Do you think it would have been more difficult if you taking summer classes?
Well, no, because I worked at NPS and I also had another job that paid me. So, so I did both of those, and I worked about 30 hours at NPS and 20 hours at the other one. So I mean, that's just going to school sort of thing.
Yeah.
And you were able to get out of here in 2 years?
Yeah, I really packed my semesters because
Did you work during the semester or no?
I did, yeah.
Wow.
I worked a lot, yeah. Some advice I can give to you guys that I kind of regret was rushing to get out of and transfer, because I mean I took several 20-unit semesters. At one point I had a 22-unit semester, and I did okay, but like, well, I did good, but I don't know. In the end, I could have spent another year at MPC and really been more confident before I transferred. I mean, when I first transferred, I like hated being, at UCSD because it was all so new to me, and I was like, I miss MPC. I wish I had like stayed another year, because it was so nice being here, and I was like close to home and all this stuff.
Yeah.
So, I mean, I think at the end of the day, 2 years versus 3 years doesn't make a huge difference. I like just made this decision like within myself that I wasn't gonna rush finishing my school at UCSD, kind of like I did here. So like I could finish in 5 quarters, but why do that? I could take like, another quarter, have a better experience overall, do better in my classes, So, that's just me, but yeah. Any other questions?
Did you go to San Diego because of the engineering program, or really because you had the opportunity to judge or university that taking you now?
Well, I was accepted into a couple schools, so I didn't have to go to San Diego. But I went to San Diego because they had a good engineering program and what I wanted to do. And some other advice that I can give you guys was like, when I was applying to transfer, I really, really, really wanted to go to Berkeley, but I didn't get into Berkeley. I was actually rejected 3 times. Once out of high school, once when I applied to transfer, and then I appealed my rejection, and that also got rejected.
Wow.
So I really wanted to go to Berkeley, but I think it was like a blessing in disguise that I didn't end up going there, because I love San Diego, and I really wanted to choose a school based on like ranking. I wanted to be Berkeley, like one of the top premier universities. But I mean, San Diego is also like a great school, so I would look into location and like all these other factors that really play a role in your experience at school. So, yeah.
Yeah, what other schools were you considering?
Davis, Santa Cruz, and I think I applied to Irvine. I don't. Davis, Santa Cruz, Irvine, and Santa Barbara. Yeah. I don't remember if I applied to Irvine, but those were the 6 that I applied to. So Berkeley, Davis, Irvine, San Diego, Santa Barbara, and Santa Cruz.
What were you choosing between that in terms of what you got accepted in?
So I got accepted everywhere except Santa Barbara and Berkeley. So I was choosing between those schools. If you love a beach town, San Diego is like perfect for that.
It's a blast, yeah.
What do you want to do after San Diego?
So also, I decided this over summer is I'm gonna go to grad school. So
Awesome.
yeah.
For a master's or?
For a master's, yeah. I'll probably end up going to San Diego again, UC San Diego for my master's. But I figured why not, get it done now while I'm still fresh.
Well, you seem to enjoy the education part, and that's that's
yeah.
an excuse to stick around longer too. So yeah.
Exactly.
Yeah.
I don't have to worry about going and working full time.
Now, do they when you get accepted to grad school, do they like a lot of times you can get like research? So it's pretty much free to stick around. You don't earn a lot of money, but you don't have to pay a lot of money. So
yeah, that's what I'm looking into right now, is because I believe if I TA like 2 classes, I get my tuition for free. So
sure.
Yeah, and I'm also looking into working in a research lab this coming year, so that will also help my chances with grad school. maybe I'll love it so much I'll go for a PhD. I mean, not even thinking about that right now.
How many years is it master's program?
So we have it's called like +1.
Okay.
So if you did your undergrad at the UCSD, you can do another year and get your master's, but it's in computer engineering.
Okay.
So I can't choose another discipline
I see.
if I wanted to. Yeah, but I also don't have to take the GRE.
The GRE, yeah.
Yeah.
Cool.
But I'll be applying to other schools as well. So.
Cool. Any other questions? Well, thank you. Thanks a lot, Amir.
Email them. It's always, I really love when people come back, and you might find yourself coming back sometime, and want to share what you learned, or if you graduated. People here as well.
I was in the intro to engineering class my very first semester, and I remember Tom brought in someone here, and I don't know. I just remember thinking like, he's so far ahead of me, but like really, it's just another year or two, and then you guys will be in the same spot.
It's just fun. Yeah.
Yeah.
You learn a lot really fast here.
Yeah.
So.
Thanks for having me. Yeah.
Thanks again.
Great. Well, we're gonna spend the rest of the class then finishing up the second MATLAB lab. And let me stop this recording.